All right, guys, I'm going to go ahead and start out with a couple questions from a former student that's in college that asked me to help them out. So I'm going to knock these two quick questions out. They're not terribly bad, but they are business calculus, so they won't connect to the geometry algebra 2 that you guys may be watching. Okay, so let's look at the first problem it asks us to do. It says f of x equals x minus 4 over x, and it wants to know f prime of x, means it wants a derivative. So before I even take the derivative of this, I want to write this fraction into an exponent, and I want to get x minus 4x to the negative 1, and then I'm just going to do my basic power rule. So this is going to come down to be 1, because then x 1 minus 1 is 0, x to the 0 power becomes 0, minus, bring my negative down, so it becomes a negative 4, so plus 4, subtract 1, x to the negative 2, so my derivative is actually 1 plus 4 over x squared. It's easy enough. Once you have the derivative, it asks, what are the critical points? Well, just set this equal to 0 and solve. So we get 0 equals 1 plus 4 over x squared. Let's just subtract. Yeah, let's just do it this way. Equals, common denominator is going to be x squared plus 4 over x squared. Or since this is set equal to 0, we know x cannot equal 0 because of the 0 in the denominator. So now we have x squared plus 4 equals 0. I do something wrong? Look at x squared equals negative 4, which means x would equal plus or minus 2i, which wouldn't be a critical value of this. So the derivative's right, I know that. That's easy enough. So minus a negative, that becomes a 1. That's easy enough. Even if I subtract 1, multiply, yeah. That's really weird. I think I did something wrong on that. I don't think the derivative's wrong. Yeah, it would be does not exist then. It would definitely be does not exist if you get a 2i. And then where it's increasing and decreasing. Really, I would just pick points here. Because these critical values is generally where you're going to see where it's increasing, decreasing. So I would probably just graph this and look real quick to see where it's increasing and decreasing. I can do that real quick. Let's see. And we'll graph it, graph the original. Willing to bet it's always increasing because everything's going to be positive from the derivative. You'll never get a negative answer, which means that your slope will always be positive. X minus 4 divided by x. Yeah. You have some inflection points, but you don't have actually any critical points. It's a unique graph. Let me show it to you. Where's my display? So here's the graph right here. I don't know if you can see my mouse, but the graph right here, it's increasing everywhere. There's nowhere where it's not decreasing, which actually makes sense with the derivative. Because did I just do? I just took my picture off. There I am. The derivative, everything here is going to be positive. No matter what number you put in for x, you're always going to get positive. So the slope's always positive. So it's going to be increasing everywhere. All right. So that one, not terribly bad. I think you pretty much finished that one off. It says so that's it for that one. Let me go to the other problem. This one we're going to use what's called the quotient rule to find the derivative. Kirsten, just be patient. I'm helping a former student that's in college with his business calculus. This is nothing that y'all have to do at all. This is a college class, okay, Kirsten? All right, so that one was easy enough. Let's look at this one. We have x squared minus 25 over x squared plus 1. They say this is f of x. Yeah, it's something to look forward to for sure, Kirsten. This is fun. All right, so the quotient rule is going to be f prime of x g of x minus f of x g prime of x all over g squared of x. Okay, let me make sure I wrote that down. Seeing how I had to look it up, I wasn't 100% sure if I was right. Nope, these are backwards. So it's f g prime and then f prime g. Glad that my prime's backwards. Okay, quotient. No, I was right. I was right. It's f prime then g prime. Okay, so easy enough. My f of x for this formula is my top formula. So I want to say my f of x, don't be confused with this f of x, is x squared minus 25. F prime of x equals 2x. My g of x is the bottom here, which is x squared plus 1. So my g prime of x is 2x. Those are easy enough derivatives to do. Now we just plug it into our formula. We're going to do f prime of x. So this f prime of x for this whole function here, not this one, is going to be my f prime, which is going to be 2x times my g of x, which is x squared plus 1, minus my f of x, which is x squared minus 25, times my g prime of x, which is 2x, all over, was it g of x squared? It should be just g of x squared. And, yep, g of x squared. So now we just have x squared plus 1 quantity squared. Now we just simplify this. We've got 2x cubed plus 2x minus 2x cubed minus 50x all over, I'm just going to leave this as x squared plus 1 squared. Doesn't really matter too much. This is never going to get to 0 because you'd have to have a negative 1 here. We distribute. We get 2x cubed plus 2x minus 2x cubed plus 50x all over my x squared plus 1. Combine like terms, these cancel. This gives me 52x over x squared plus 1 squared. So there's my derivative. That's easy enough. Hey Marcus, what's up? How's college for you? Let's see. From here, it asks for the critical numbers, just like before. So just take this, set it equal to 0. We have 52x equals 0. Last time I checked, x equals 0. That's my inflection point. To see where it's increasing or decreasing, do the first derivative test. Put your 0 here. Pick a number easy to do math with over here. Let's do negative 10. And let's do 10 over here to do math with. If I plug it in here, my bottom's always going to be positive. So this is a positive and a negative. So this is negative. That means it's decreasing from negative infinity all the way up to 0. And then I put 10 in there. That gives me a positive over a positive. This is positive. So this graph is increasing. Increasing from negative infinity up to 0. And of course it can't touch 0 because at that point the slope is 0. It's not increasing or decreasing. And it's decreasing from 0 to, no, these are backwards. It's decreasing from here and it's increasing here from 0 to infinity. Done. Not bad. So yeah, Kirsten, a lot of my students, once you're my student, you're my student. And I've always had kids come back and ask me questions even when they're out. Let's see. Day 4, Week 4, day 3, number 2, geometry. I feel like it's really simple, but I'm confused. All right, cool. And Kirsten, you're the same, so let's knock that out. Ethan, I hope that helped you. Hope that helped you, sir. Those are really just basic derivatives, which is one of the very first things you cover in regular calculus. So if you could do this, dude, you could do regular differential calculus. Differential calculus will have some more concepts that business calculus does it, but it's the same ideas. All right, so y'all said week 4, day 3, number 2. Well, 2 through 6. Nice, Kirsten. So week 4, day 2. Week 4, day 2, number 2. Okay. So this one's talking about a square. So it says find the values of x and y that make the quadrilateral GHJK a parallelogram. If all angles in the quadrilateral of GHJK are right, is it a square or rectangle? Okay, so easy enough. Let's do number 2. What do you mean 2 through 6? Are you Kirsten, are you talking day 3, young lady? Oh, day 3. Okay, cool. Day 3, number 2. All right. If the sum of the interior angles of a regular polygon is 1,260 degrees, name the figure. Okay. So we need to know how many sides there are so we can name the figure. So we have a formula that says n minus 2 times 180 equals my sum of my angles. Ethan isn't sure what the critical number would be. It should be 0. That's your critical value. It's when you set your derivative set equal to 0. That is a critical value. That's actually where, in fact, there's a change of concavity at 0. I don't see that in the... Yeah, there's only me today, so trying to moderate the chat and work problems is a little... All right, Garen, I'll get to you in a second, okay, dude? Okay, so we have this formula that's our sum. And the problem, it tells us the sum of the interior angles is 1,260. So we use our formula to find the sum, but now we're going to look for the number of sides. So now we're just going to solve this out. So we're going to divide both sides by 180. And this is going to give me n minus 2 equals 1260 divided by 180. Gives me 7. We just add 2 to both sides. We get n equals 9. And then if you remember, if you look at the top of the page, now the 9-sided figure is called a nonagon. And that's it for number 2. For a large part, Kirsten, I don't want to work every single problem because I'm doing the work for you. But I'll work one other one that you ask. Until then, until you decide which one you want to ask, I'm going to jump over to answer Garen's question. All right, so Garen, you want week 3, day 5, number 3. Yeah, a lot of times the problems, you overthink them. So week 3, day 5, number 3. So 4x squared minus 3x over 4x squared minus 1 times 2x plus 1 over x. This is the one you're talking about, Garen? Yeah, a lot of times people overthink problems way too much. I'm guilty of that too. So I'm going to work this problem. Here we go. First thing you need to do with rational functions is factor everything. Factor, 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 factor. This top has a GCF of x. So I take an x and I have 4x squared minus 3 over, well, this bottom is a difference of two squares, which would give me 2x plus 1 and 2x minus 1. We're going to multiply this by 2x plus 1 over x. Now that this is simplified, we can actually find the numbers that x cannot be by setting these each not equal to 0, and we can get x does not equal 0, 1/2, and negative 1/2. So we know we're going to need that for my domain. All right, from here, let's look. Anything top and bottom cancel? No. Anything top and bottom cancel? No. When you multiply your fractions, you're allowed to look at your diagonals and cancel. This 2x plus 1 becomes a 1, and this 2x plus 1 becomes a 1. There's an x right here and an x right here. They both become a 1. So this simply comes down to 4x squared minus 3 over 2x minus 1 times 1, which is just 4x squared minus 3 over 2x minus 1. My domain is simply the set of all x's such that x is an element of the real numbers, and x cannot equal these numbers. So negative 1/2, 0, and 1/2. So not terribly bad. Got to be able to factor. Factor and cancel. Factor and cancel. That's how I set every one of these problems up. Is factor and cancel. Factor and cancel. Kirsten, you know which problem you want done? All right, so we'll look at 3. Let me note down when I'm actually doing these so I can actually go back into the comments and put in at what time I'm doing these videos. So Garen's was about 17:30, well, about 17:10. And this is 4:09. And then the geometry one, I have to go back and look at that. All right, so let's look at number 3 then. So this is going to be at 17:52. All right, so number 3, it says if the sum of the interior angles of a regular polygon, number 3, what would the measure of the exterior angle of a heptagon? What would the measure of an exterior angle of a heptagon? Round your. All right, so all exterior angles of a polygon equal 360 degrees. If we know they all equal 360 degrees, we just need to know how many number of sides a heptagon has. So I go back and look at the top. And a heptagon should be 7 sides, so we just simply do 360 divided by 7. That's it, 360 divided by 7. So all exterior angles add up to 360. A heptagon, if you look towards the top of the page, a heptagon is 7 sides, so to find the measure of each of them, because they're all going to be the same, just do 360 divided by 7, and this is round to the nearest hundredths. So 360 divided by 7 gives me 51, well, it's approximately 51.43 degrees, hence hundredths place. And it is 28, so it was 51.428, but because I have an 8 in the thousandths place, I'm only going to the hundredths. I'm going to add 1 to the hundredths place because it's greater than 5. And that's that. What else, guys? What else? What else? What else? Day 7. Huh. You're welcome, Kirsten. Day 7, guys. What else? There is no day 7. Oh, you mean number 7? Wow, this looks an awful almost lot like Ethan's problem, except not calculus. Yeah, I got you. Same day, number 7. Listed at 20:05. 49. Hey, before I start this, I'm going to try do a highlight. No, I think it's going to be easier for me just to write it down and go back and type it in the comments. Okay, so we have 1 over x minus 1 minus 2 over x squared equals 0. All right, to subtract fractions, we need to have a common denominator. To get the common denominator, we need to make sure everything is factored to see what's missing. Everything is already fully factored. This does not have an x squared in the denominator. This does not have an x minus 1 in the denominator, so I'll multiply by the number 1. What I'm going to multiply this number 1, this by is x squared by x squared. There's still 1, except I'm going to multiply it by this, so I can get the x squared in the denominator, but I don't change the equation. Here I have 2 over x squared. Well, it's missing the x minus 1, so I use the x minus 1 as my number 1, so I can actually get x minus 1 in the denominator. From here, my numerator, when we multiply straight across, we're going to get x squared, and then minus, we've got 2 times x minus 1 all over my now new common denominator of x squared times x minus 1. All right, hippity hoppity distributive property. We now have x squared minus 2x plus 1 over x squared times x minus 1. Let's see. This top factor is 2. X squared minus 1. Well, x minus 1 times x minus 1, because that would give me a positive 1 and a negative 2 all over x squared times x minus 1. Beautiful. At this point, I already know that my domain is actually going to be the set of all x's such that x is an element of the real numbers and x cannot equal 0 and 1. That's easy enough because I just set both of these equal to 0. Now we simplify, and I have an answer of x minus 1 over x squared. That's the answer right there. So don't forget to simplify. But that's actually a nice problem. You work it out and then simplify at the end. What else? What else? Garen, I sent you stuff to help you on your English 3 project. Even though I'm not an English teacher. I sent the information that you asked for, except for one thing, and you'll see it in the email. What else? What else? What else? All right, Kirsten, you too. Have a good day. Have a good weekend. No problem. Questions, concerns, comments, rude gestures. Kind of miss saying that in class. Questions, comments, rude gestures. The look on y'all's faces the first time I say it in class, y'all like, what? He really just say that? Week 4, day 2, number 3. Week 4, day 2, number 3. All right, let's see. This is at 24. Perfect. So we have 2x over x squared minus 36 plus x plus 4 over x plus 6. Easy enough. Factor everything that needs a factor. We have 2x, and we now have x plus 6, x minus 6 is the difference of two squares, plus x plus 4 over x plus 6. Okay, so if I look here, this already has an x plus 6 in it, so I don't need to do anything to this first one. So I can leave this first one alone. But the second one, I need to multiply by an x minus 6 because that's what's missing in the denominator. So I have an x minus 6 over an x minus 6. So this will give me the x plus 6, the x minus 6 on my denominator. Here we're going to FOIL. I want to get x squared minus 2x minus 24. So that's simple enough. Now we just simply add. So we're going to get 2 plus, and we just add these, 2 plus 24, that's going to give me, or 2 plus a negative 24 gives me a negative 22. So we're going to get x squared minus 2x minus 22 when I add 2 to it, over x plus 6, x minus 6, 22, let's see, 1 and 2, well, 1 and 22, 2 and 11, 3 no, 4 no, 5 definitely not, 6 does not, 7 does not, 8 does not, 9 does not, 10 definitely. So that's it. So this doesn't factor. So that's it. You're done. Your domain, just look at the bottom here. We know that my domain is going to be the set of all x's such that x is an element of the real numbers. And x cannot equal, by setting these, both of these equal to 0, I'll get negative 6 and 6. You can write it as plus or minus 6. I don't really care. All right. What else? What else? What else? What else? Change color markers here. What? Oh, well, whatever. Just then it goes to x. It would just, you're adding it. So it's just x squared minus 24. What do you mean it was a wrong problem? It said number 3. You said number 3, buddy. Yeah, I just dropped my x randomly. Everything else is the same. Just put an x in there and then just combine like terms. Instead of doing negative 22 plus 2, do 2x minus 2x. Yeah, I just wrote it down wrong. Oh, my dog's down there. It doesn't change the math. Doesn't change the concepts. Everything else is good. Oh, removable discontinuity. I'm in the wrong packet. Yeah, I'm in the wrong packet. So, removable discontinuity number 3. Okay. Let's do the actual problem you asked for then. 2840. All right. Sorry about that, Garen. I was in the wrong packet. I have so many packets here. So we have 2x squared minus x over 6x cubed minus 21x squared plus 9x. Okay, first things first. Factor, 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 factor. So I'm going to factor out a greatest common factor on top. I've got an x, which gives me 2x minus 1. I'm going to factor out on the bottom, I have a 3x. And that leaves me with 2x minus 2x squared minus 7x plus 3. This factors. So I have x times 2x minus 1 over 3x times. This factors to, let's see, I have 2x squared minus 6x plus a negative x plus 3. This gives me a 2x, and this leaves me with an x minus 3, minus 1, x minus 3. So this factors to 2x minus 1 and x minus 3. All right, so now that we have it fully factored, we can look for the removable discontinuities. My x's cancel, so I know I got to do x equals 0. My 2x minus 1's cancel, so I have to do 2x minus 1 equals 0. My reduced function simply becomes 1 over 3 times x minus 3. Well, let's simplify that. I get 1 over 3x minus 9. So this is my simplified function so far. So we know 0 doesn't work. So for this point, when I plug 0 back into this equation, I'm going to get 0 and then 1, let's see, 1 over negative 9. So a negative 1/9. So there's the first hole. Here, I'm going to add 1, divide by 2, x equals 1/2. So we're going to plug this back into here. So I'm going to get 1 over 3 times 1/2 minus 9. This gives me 1 over 3 halves minus 18 halves. This gives me 1 over a negative 15 halves, which gives me negative 2 over 15, just basic arithmetic. So this point becomes 1/2 negative 2 over 15. Not terribly bad. This was a little bit more difficult with your fractions, but not terribly bad. All right, so what this is, Trey, is I have students asking me questions and I'm answering questions. This problem I just finished up on was Algebra 2. So far I've answered a question for Algebra 2, Geometry, and a former student with some calculus in it. All right, so let's see. You want number 6 from this week, day 3. What would you do with the same thing on? Oh, so on number 3. Let's see for number 6. Let me just look at it. The sum of the interior angles of a regular polygon is 1,260. Kind of, sort of. You would definitely do that to, you have to know the number of sides. Once you know the number of sides, you just do 360 divided by. So yeah, it's like the one we just did on number 2. You have to solve for the number of sides. Once you know the number of sides, just do 360 divided by that number of sides, and you have your answer. Do you need me to work it out, or is that good enough for you? Forget it, I'm just going to work it. All right, Hosford, I'm just going to work this for you. So let me write down this time. Yeah, I'll work it. So 3:30. 33:26. All right. Somebody else send me another. I had a student send me another picture, so I'm going to look at that one to see. All right. Let's see this one. So we have my n minus 2. That's an n. Times 180 equals 2160. Divide both sides by 180. So we're going to get n minus 2 equals, let's see, 2160 divided by 180 equals 12. We add 2 to both sides, so my n equals 14. The sum of all of my exterior angles are 360 divided by 14. 360 divided by 14. And that gives me approximately 25.71 degrees. So each exterior angle would be about 25.71 degrees. So the first bit of the problem, and then the very next problem after that, in the number 3, where you had so it's a blend of number 2 and number 3 together. All right, Ethan, let me look at your problems. So Ethan, what are you asking on this? The critical value? Your derivatives, right? Your critical value, you set them equal to 0 and solve. So you have 6x squared minus 4x cubed. Just set this equal to 0 and solve. So we have 0 equals, factor out the greatest common factor, 2x squared. Leaves me 3x minus, no, just 3x, just 3. And then this is 2x. Now we do the zero product property. So here x is going to equal 0. Here x is going to equal 3/2. Those are the x values. If you need the y value, plug it back in your position function, f of x. If it wants a point, these are your x values. Go back to your f of x and plug them back in. So you'd find f of 0 and f of 3/2. And then increasing, decreasing is just the first derivative test. Put them in order, 0, 3/2. Pick a number fairly large, -10. A number in between here, I want to pick 1. And a number really large is 10. Plug them back into your derivative. I'm going to do this one here. This becomes a positive number. This is a negative, so this is negative. I'll put a 1 here. This is positive. This is positive. Put a 10 here. This is negative. So this graph is looking kind of like this. Something like that. That means it's increasing everywhere there's a plus, which is going to be between 0 and 3/2. It decreases from -infinity all the way up to 0, union. Now this ain't right now I'm not doing MD, I'll do geometry in a second. I already worked that problem. We're going to jump to 3/2, and then we're going to go to infinity. So that's where it's increasing and decreasing. I don't know what they mean by the critical values. That's the only other picture. That's the newest picture you sent me. So yeah, your derivative's right. The critical values, x equals, it should be just x equals 0 and 3/2. Because these are your critical values, these are your test values. Use the test values first derivative test to find out where it's increasing and decreasing. I don't know if they teach all the number line to do the first derivative test, or they actually make you do this formal math, like with all the number line is much easier. It's just like the inequality test that I taught you many years ago. All right, MD, I'm going to work that problem again. Pretty sure I worked that problem, but this way I can actually have a timestamp on this one. All right, so you want week 4, day 2. Oh, I haven't worked that one. Day 2, question 2. Alrighty. So this one right here, you're given a quadrilateral. And then this is G, H, J, and K. This is 1/3 Y plus 5. This is -x plus 9. This is -3y plus 15. And then this is x plus 3. Okay. So, MD, is this the problem you want? Pretty sure it is. This is day 3, or week 4, day 2, number 2. All right, so first things first, let's set these. We want to know what value of x and y is going to make a quadrilateral a parallelogram. So if we remember back with parallelograms, we know that my opposite sides have to be congruent. So these sides and these sides here have to be the same length. So we just set these equal and solve. So I have 1/3 y plus 5 equals negative 3y plus 15. Let's see. Let's subtract 5 from both sides. Add 3y to both sides. So I'm going to have scratch work over here, 1/3 plus 3. This gives me 1/3 plus 9 over 3, which gives me 10 over 3. So this becomes 10/3 y equals 10. Multiply both sides by the reciprocal. I get y equals 10 times 3 over 10. So we're doing 3 over 10 right here. These cancel out, and that's why we're doing it. This is over 1. So y equals 3. That's easy enough. For the x, it'll be a little easier because there's no fractions. We have a negative x plus 9 equals x plus 3. I'm going to add x to both sides, subtract 3. And I'm going to get, what is that? 6 equals 2x. Divide both sides by 2. X equals 3. All right, so x and y equal 3. Now, you got 10 over 3. That's what I got, 10 over 3. All right, so well, that's 10 over 3, y equals 10. You have to finish it out. So we got y equals 3 and x equals 3. Let's just plug them in and see if this works. So I'm going to put, let's see, my y as 3 here. So I've got 1/3 times 3 plus 5. This gives me 1 plus 5, which gives me 6. So we know that these lengths right here are 6. Now let's put 3 in here. We have x plus 3, which is 3 plus 3, which is 6. So this length here and this length here is 6. Now, because all 4 of my sides are the same, and it says assume if all these angles are right. So if these are right angles, so we have a quadrilateral that has 4 right angles that have 4 sides that are congruent. This is a square. That would be a square. Not a terribly bad problem. All right, what else? Day 3, question 1, still geometry. Okay. So I can't draw this figure. I cannot draw this figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what you have to do is you have to count the number of sides. And it has 10 sides, so n equals 10. So all I did is I just started at one point and counted all the way around the paper. So 1, 2, 3, 4, just count all the way around to 10. And then it says, given the following regular polygon, so you had to count the number of sides, that's the key. What would the measure of each individual? So if I know n equals 10, I know all the angles are going to be the same. I can use the formula n minus 2 times 180 to find the sum of the interior angles. And then we will use this to actually find each individual interior angle. So we have 10 minus 2 times 180. This gives me 8 times 180. That should be 960, but let me double check. 8 times 180. Not even close, 1440. Woo, I'm glad I double checked. So I know for a 10-sided figure, a decagon, the sum of my interior angles are 1,440 degrees. Now, all I'm going to do is divide it by the number of angles I have, which is the same thing as the number of sides I have, which is 10. So I divide this by 10, and I'm going to get my individual angle of a decagon is going to be 144 degrees. Easy enough. Easy peasy, lemon squeezy. N is the number of sides. So let me just pop up a decagon. So n is the number of sides because I counted when I did this. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So because there's 10 sides, we get n equals 10. Hi, Via, or V, Via. All right, what other questions you guys got? That was right about 45. What else? What else? What else? You're welcome, Garen. Day 2, question 1. You're trying to get me to work all the problems, huh? So I'll work one of them, but I will not work both of them. So I'm going to do A. I'm going to do 1A on day 2 for the squares. So I have point A, which is -4, 2. I have point B, which is 0, 3. I have point C, that's a C, which is 1, -1. And then I have point D, which is -3, -2. All right. And then, okay, you're just checking your answers. So here's how this kind of works. We want to know, is this a rhombus, a square, or a rectangle? So first thing I'm going to do is I want to check to see if I can eliminate one of those two. And I want to use the distance formula. So I'm going to sketch this to know my sides. So I have -4, 2. This is A. I have 0, 3. This is B. I have 1, -1. This is C. And then I have -3, -2. All right. Not the best of drawings, but oh, this 3 is supposed to be above it. It's supposed to be up here. Something like that. All right, A, B, C, and D. All right, not the best of drawings, but we can get the idea. So I need to find my distance of each one of these. So let's find AB. From that, I'm going to do my distance formula. My distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we're going to use the distance formula. So let's do the distance formula. We have to do it for all 4 sides. So we're going to do, let's do my 0 minus a -4 squared plus 3 minus 2 squared. This should give me 4 squares, going to give me a 16. This gives me a 1 square, so plus 1. So this becomes the square root of 17. All right. I don't need any further than that because what I'm going to look for is square root of 17. All right, so let's do DC. This will prove it's a parallelogram because it's not a parallelogram. It can't be either, any of them. So DC, so here we go. So we're going to do -3 minus 1 squared plus -2 minus a -1 squared. -3 minus 1 squared, -2 minus a -1 squared. This gives me 4. This gives me 16. This gives me a -1 squared, which is 1. Take the square root of it and square root of 17. So now we know that AB and DC are congruent. This actually makes it a parallelogram. So now we just do AD. So AD We're going to do the same thing. -3 minus a -4 squared plus -2 minus 2 squared. Take the square root of it. And this gives me what? 1 squared, which is just 1. This gives plus 0. Square root of 1 is just 1. All right. -3 minus, well, I'm just rolling with it. That seems kind of weird. All right, so that's AD. Now let's do BC. Should get the same thing. So we're going to get 1 minus 0 squared. You got 16. Oh yeah, duh, because this is 4. It's -4. This gives me 16, which gives me the square root of 17. Hoorah. All right. So from there, we've got that. And then BC, -1 minus 3 squared. This is going to be the same thing. It's going to be the square root of 17. So right now, I know this is not a rectangle because all 4 sides are the same, and a rectangle, not all 4 sides are the same. So this either has to be a rhombus or a square. So the way we're going to figure this out is I'm going to pick one of these lines, and I'm going to check the slopes. And if the slopes are negative reciprocals of each other, they form a 90-degree angle. They're perpendicular. That would mean all my angles would be 90 degrees. So either it's a 90-degree angle now or not a 90-degree angle. If it's a 90-degree angle, it's a square. If it's not a 90-degree angle, it's a rhombus. So let's do the one with 0 in it. So let's do AB. So AB. So we need our slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, here we go. 3 minus 2. So this is slope of AB. This gives me 3 minus 2 over 0 minus a -4. This gives me 1 over 4. All right. So what I would be looking for when I do the slope of BC would be a -4. So the slope of BC. All right, so here we go. 1 minus 3. So -1 minus 3 over 1 minus 0. This gives me a -4 over 1, which is -4, meaning that these are negative reciprocals. This means that segment AB is perpendicular to segment BC. Perpendicular means that these are 90-degree angles. Now, because this is a parallelogram, we know the consecutive angles are supplementary. It makes this 90 degrees, makes this 90 degrees, makes this 90 degrees. So now I have a quadrilateral that have 4 sides that are congruent with 4 90-degree angles, making it a square. And then you do the same process with the other one. If it's a rhombus, these would not be negative reciprocal. So I'd get like a slope of like 3 or something. If the slopes are not, so we have a 1/4 and a -4. So if I flip this over, change the sign, it becomes -4. But if that does not exist, so let's say this was 1/4 and this was 3, that, or -3, that doesn't mean, that means it would be a rhombus, because that's the only way it's a square is if you have negative reciprocal slopes. If you do not have negative reciprocal slopes, then it's a rhombus, because it could be any other degree other than 90 degrees or even 0 degrees. What else? What else? What else? Anything else? That's been an hour. Hour straight of problems. Haven't had that in a while. Any more questions? Week 4, day 1, question 1, letter B. Week 4, day 1 on B. See if it's a rhombus. Believe it or not, that is a lot like what we just did. Do the distance formula 4 times. If you get all the same answer for the distances, it's the same. But let's do this. So we have point A, which is 110. We have point B, which is -4, 0. We have C, which is 7, 2. And we have D, which is 12, 12. Do a rough sketch. So 110, -4, 0. 7, 2. And 12, 12 way up here. So something that looks like this. All right, we want to see if it's a rhombus. So this was A, B, C, D. So we need my distance of AB. So here we go. We've got same distance formula that we just used. So we've got -4 minus 1 squared plus 0 minus 10 squared. Take the square root. This gives me -5, which gives me 25 plus 100. Take the square root of 125. I could care less if I finish that out, because if everything comes down to the square root of 125, then it's a rhombus. All right, so we've got AB, BC. So we're going to do 7 minus a -4, 7 minus a -4 squared plus 2 minus 0 squared. We're going to take the square root. And this gives me 7 plus 4, which is 11. 11 squared is 121 plus 4. Take the square root. Gives me a square root of 125. This looks good, because now I know 2 sides that aren't even consecutive. So let's do CD. So we're going to have 12 minus 7 squared plus 12 minus 2 squared. 12 minus 7 is what? 5. 5 squared gives me 25 plus 100. Take the square root of it is the square root of 125. And last but not least, we would do AD. Don't really need to do AD at this point, because you know it's a parallelogram, so we already know it's going to be the square root of 125. But let's do it anyway. So we're going to have 12 minus 1 squared plus 12 minus 10 squared. Take the square root. This gives me 11, gives me 121, plus this gives me 2, which squared becomes 4, which gives me the square root of 125. So it is a rhombus because all 4 sides are the same. All 4 sides are the same length. It's a rhombus. Depends on your teacher, MD. I don't really care. For my students, I don't really care. But if your teacher wants you to go 5 square root 5, then for sure. But really the way the question is asked is determine whether, if you can simply make a statement saying, hey, these are all the same. You could break the square root down. That's really teacher preference. If you're my student, I don't really care. These all are the exact same number. You'd have to ask him. I don't know. To play it safe, I would go 5 square root 5 just to play it safe, because at worst, that you give him more than what he wants. What else? What else? Well, guys, I'm going to shut this stream down. I'll be back up at 5 o'clock tomorrow if you have more questions. You don't have to use a slope formula on this one because we're not talking anything about angles. For it to be a rhombus, it only has to have 4 congruent sides. That's it. No, yeah, I'm done for today. You can come back up. I'll be back up at 5 o'clock tomorrow. But for this rhombus, you don't need to do anything with slopes. That's only with the squares. A rhombus only has 4 congruent sides, and we can show all 4 sides are congruent, so you're good. All right, guys, I'll be back at 5. I will see you then.